Hello and welcome to this session. My name is Musa Peter. In this video, we will be learning about Python sets. We will also look at what a set is, how to create one, and also how to use it to store unique values and also perform basic operations. So by the end of this session, you should be comfortable working with sets in Python. So let's dive in. So what is a set? A set is an unordered collection of unique items. And you can think of this as a bag of items. Previously, we had discussed about tuples and also lists. These are actually different data structures. And we said that data structures, they are actually like containers. They are containers that are used to store data or even to house data. So a set is an example of a data structure. And in this case, it is usually a collection of unique items. So a set contains unique items. And these items are usually not ordered. They are not ordered. It is actually the opposite of a list and a tuple. For lists and tuples, we say that they are usually ordered, but a set is usually made up of unordered items. So you can think of this as a bag of items whereby you cannot have any duplicates, a bag containing items, and you are not allowed to have any duplicates within that bag. And then the items have no specific order. The items are just arranged without a specific order. And then the other one is that you can quickly check if an item exists. So you can think of it as a bag, maybe a bag containing pens, a book, a pen, a book, maybe a set, maybe a mathematical table, and very many others. So in this case, a set contains unique items, and you can be able to check whether an item exists within that specific set, and you're not allowed to have duplicates. So those are the basic characteristics of a set. But besides that, it goes without mentioning that a set is majorly made up of items that are unordered. So in this case, there is no indexing. There is no indexing within a set. You cannot be able to determine the index of a specific value within a set because there is always no order. Then the items are usually unique. That means that Python automatically removes duplicates in this case. So the items are usually unique. And then a set is usually mutable. You can add or remove items from the set. You can actually add or remove any items from the set. There is always no indexing. So you can't access any items by their positions in this case because they do not follow a specific order. The values or even the items are usually unordered. So they are just arranged within the container without following a specific set. Without following a specific order. And then there is a fast membership testing. You can be able to quickly check if an item exists within that set. And then apart from that, sets support these mathematical operations like union, intersection, and also difference. So we can be able to union any two sets. We can be able to find the intersection, and we can also be able to find the difference. So that is what we are going to be discussing about this specific data structure, Python data structure, which is sets or even a container for housing data. So the general syntax for a set is this. This is the general syntax. So what you do is that you write the name of the set. This gives us the name of the set, and then is equals to. And then we have the different items of that set enclosed within curly brackets. So the values that make up the set are usually enclosed within a curly bracket. So without the key value pairs like dictionaries. So in a set doesn't have what we call the key value pairs. We are going to be discussing about these key value pairs when you'll be dealing with dictionaries. So a set contains different items listed within the curly brackets, but separated using commas. So the syntax is the same for a tuple and a list. The only difference is the type of brackets that we use. For a set, we use curly brackets. For a tuple, we use parentheses. And for a list, we use square brackets. Okay, so when do we use these sets? When do we use these sets? Sets are majorly used when we need to remove duplicates. Assume you have information whereby you're not required to have any duplicate records. What you do is that you make it a set. And by doing that, you'll be able to remove duplicates. You can also use sets when you need to check if an item exists within a specific maybe data. So if you want to check for the presence of a specific item, then you use the concept of sets in this case, or even you can make it a set. And then when you need mathematical set operations like union, intersection, and very many others, difference, and very many others, then you use the concept of sets. So sets are actually used in a variety of ways, and we are going to be giving examples or even discussing about the different ways in which we can use sets. Now, before that, we've said that the general syntax for a set is this: my set, then is equals to, and then you list the items separated by commas, and then you enclose them within curly brackets, within these curly brackets. Okay. Now, how do we create sets? How do we create sets? I'm going to be giving examples of different sets that I created in this case. So assume you want to come up with a set containing fruits in this case. So you name your set fruits. You can give it a different name. So in my case, it is fruits. And then we have the different fruits that are making up my set. And if you observe in each of these, the values are actually separated using commas. They're actually separated using commas. And then since the data type in this case is a string, we have enclosed each one of them with single quotations. We can use single quotations or double quotation marks. And then we enclose the 3 items using curly brackets. That is what makes it a set. So anytime you use these curly brackets, most of the times Python would recognize the values within as a set. That is, as long as there are no key value pairs, Python is going to recognize that as a set. So now we want to print this specific string here. We want to print that specific string and then call out our set. Call out the items for our set, which is now fruits. Remember to use a comma after this specific string. Just like I said in my previous videos, this is an additional information. You can omit that. It is not a must for you to have that. You can omit that. Okay, so once we run that, you're going to see the name of, actually you're going to see the values or even the items making up the set, which is now apples, bananas, and cherry. Those are the different fruits making up our set. And then this was our string that we had typed. We can also modify this fruit set, maybe include, we can add that and then run it. So once we run that, you can see the modifications are being made down here. So that is just additional information. It was not that important. Now, you can also have a set of numbers. Remember, these are integers. So whenever you have a set which is made up of integers, you don't enclose the integers within single or double quotation marks. You just write the numbers or even the digits as they are. Same to floats. So this is our set named numbers. So we can print it out. We can print it out, numbers set, and then is equals to, in this case, it includes, and then we call out our name, the name of our set. We call it out, and it's going to display the values that are making up our set, which is now the items 1, 2, 3, 4, 5. We can also create a set with duplicates. So once we create a set with duplicates, Python will remove those duplicates instantly. They get removed instantly. So for example, assume I have this specific set. This set is called a duplicate and it contains 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. So in this case, we say that a set only houses unique items. It doesn't allow for duplication. It only houses unique items. So once we run this, Python is only going to recognize the unique items. That is 1, 2, 3, and 4. It's not going to have all the duplicates within. So once we print out this, once we print out the set, that is the duplicates, it's going to return only the values that have actually unique. So for example, in our case here, the set with duplicates removed is equals to 1, 2, 3, 4. So Python removes any duplicates. It removes any duplicates. And that is the difference between a set and a list. A list can have duplicates, but a set cannot have duplicates. It cannot have duplicates. Now, we can also create an empty set. We can also create an empty set in our case. We can also create an empty set. And just the same way that we can create an empty list, we can also create an empty set. So what we do is that we give our set a name. So for example, in our case here, it is empty set is equals to, then you proceed, or even you start your set with the word set, with the keyword set. In this case, Python would recognize that as a set. What follows would be recognized as a set. And then what follows is the parentheses, not curly brackets, parentheses. Parentheses. If you use the curly brackets, then Python would recognize what follows as a dictionary and not a set. So once we use the set, this one, then what follows is the parentheses, not the curly brackets. And then we can print out our empty set, and this is what we have. So this is our set. That is our set, and that is it. So those are the different ways in which we can create sets. We can create an empty set, we can create a normal set, and then if you create a set containing duplicates, then Python automatically removes the duplicates. Now, there is no indexing in sets. Just like we said, the values are usually not ordered. They are unordered. So you don't expect Python to award indexes or even indices to each of these values. So for example, we have our fruits set, which contains apple, bananas, and even cherry. So we can check if, for example, we have specific items within our set. We can check on that. So for example, we want to check whether apple is in fruit. So is apple in fruits? If it is there, then Python would return true. If it is not there, then it would return false. So we want to print out this. Let me separate that using Control, Shift, and then minus. Let me separate this into a new cell. Yes, okay. So what we do is that we list our value or even our item, and then followed by the in keyword. So apple in fruits. If it is in fruits, then Python outputs true. Remember, fruits was our name of the set. It was the name of the set. So apple in fruits. So if it is true, then Python returns true. If it is not there, then Python does not return true. And as you can see, apple is already there. So we expect the output to be true. So is apple in fruits? True. So the output there is true. That means that the word apple is in fruits, or even our apple is contained within our set. And then we want to check whether we have grapes. If you look at this, there are no grapes. So if we check whether grapes is in fruits, then the output should be false. The output should be false. And if we run that, you can see the output is false in that case. How do we run that? You run a cell using using Shift, then Enter, or even you can also click on this, Shift, Enter, or click on the triangular icon on top. Okay, we can also iterate through a set. We can also iterate through a set. So, for example, this is just what we have there. It is just this is just a subtopic, all fruits. So we wanted to know all fruits in this case, all fruits. And then what follows is an iteration. So we use a for loop. So for each fruit in fruits, or even for each item in the fruit set, so the items in this case, it is apple, banana, and cherry. So for each item in the fruits set, print fruits. So we print this space, or even I can call it hyphen. So we print hyphen, and then followed by the fruit. Remember, this one is not a keyword, so we can change that to item. So for item in fruits, print the item. So these are the items the apple, bananas, and the cherry. Those are the items. So we want to print each one of them. So you cannot do this. You cannot do this. This will cause an error. So you cannot print their indexes. You cannot use indexing because that one will output an error. The sets do not support indexing. So you cannot use the indexes like we were doing with majorly tuples and also lists. So we cannot use this. We cannot use indexing in that case. So if we run this, then we are going to get the fruits include cherry, apples, and also bananas. Those are the items. So for each item in the fruits, which are now the different fruits, apples, bananas, and cherry, print the fruits. Print each item. This is cherry, apple, and bananas. So we can iterate through. We can iterate through. So what we are learning is that there are no indexes. Python does not recognize indexing in this case when dealing with sets. So if you print out, for example, if you print out, for example, print, if we print, and then the first element of our set, which is fruits, if you print out that, then you're going to get an error in this case. So you can see you're getting an error. You're getting an error. So if you use the indexes, you'll get a type error, meaning that the set object is not subscribable. You cannot actually get the indexes for values within a set. Then how do we add or remove items from a set? How do we add or remove items from a set? Now, if we want to add items from a set, we can actually use all these methods. The first one, we can use the add, then the name of the item. This will add one item. We can also use update, then items. This one is used to add multiple items. So if you want to add more than one item, then you use the update item. You use the update, then items. Then you can remove, you can use the remove keyword followed by the item. This one removes the item. And if the item is not found, it returns an error. So if you are trying to remove an item that is not there, then it will return an error. And then you can also use discard item, and this one will remove the item. And if that item is not found, there will be no error. It doesn't output an error. It doesn't output an error. So majorly discard is far much better compared to remove because this one does not return an error. It searches for that specific item. If it is not there, then it doesn't remove it, and it also does not return an error. And then we have pop. Pop removes and returns a random item. It will remove and return a random item. And then the last one is clear. Clear removes all the items. So if you want to remove all the items from a set, then you use the word clear, or even the keyword clear. Let me give you some examples. So assume we have this specific set that we've been working with, fruits, which contains apples, bananas, cherry. Let us first of all print it out, run it. So we have our starting set. So the starting set, remember this was just an additional information or even a string that I wanted it printed together with my output. So the starting set contains cherry, apples, and bananas. So assume we want to add dates, a fruit called dates. So what we do is that we write the name of the set, which is now fruits, then dot add. Remember, add is used to add a specific. This one adds, it adds only one item. It adds only one item. So if you use add, remember that you're going to only add one item. You're going to add only one item. So we run that, and you can see what we have. You can see what we have over there. You can see what we have over there. So we can actually add items within a set using the add keyword. So fruits.add, and then followed by the name of the fruit that we want to add, or even the item that we want to add. And then we print out the fruits. So after printing out that, you can see that there is the word date that has actually been added. And actually there is no specific order. For example, in this case, date comes before banana. Banana was the last one. But if we add the word date or even the item date, then it is just added randomly within that specific set. Not like a list whereby after adding a specific item, that item would be taken to the last or even to the end of that list. So for sets, the values are actually randomly arranged. And then we have multiple items. If you want to add multiple items, then you use the update keyword. So in this case, it will be the name of our set, which is fruits dot update, and then followed by what we want to add. What do we want to add? Remember, in this case, we are adding more than one. That is why we are enclosing them within the square brackets. It's like a list of items that we are adding. So we have elderberry and fig. And then after adding them, we now print out the output. What is the output after adding the two fruits? So after an update, you can see we have banana, we have cherry, we have elderberry, we have date, we have apple and fig. Just the same as what we did up here, you can see that elderberry and fig, they've been arranged randomly. They've been assigned positions randomly. So there is no order in which these values are actually assigned. And then we can also remove items. We can also remove items from a specific, we can remove items from a specific set. We can remove those items using specific keywords like remove. So once we use remove, this one will remove an item. So for example, assume we want to remove banana. We want to remove banana from this specific set. From this specific set. So what we do is that we write the name of our set, which is fruits, and then dot remove, followed by the name of the item. The name of the item. Now for this case, we are using strings. So if you are using integers, then for integers, you don't enclose them in single or double quotation marks. So then we now call out our fruits after removing banana. And after removing banana, you can see we have cherry, elderberry, dates, apples, and figs. So the item banana has actually been removed. This one has actually been removed from this. We can also discard. So for example, assume, before that, let me take you through something else. Assume we are trying to remove a fruit that is not there. Assume we are trying to remove a fruit that is not there. So let me remove something like melon from that specific set. Let me remove melon. You remember that our set does not have melon. So if I remove the word melon or even the item melon from that specific set, then we expect it to return an error. It's going to return an error because for that specific set, there was no this specific item, which is melon. So what happens if you do not want to receive this error, then you use the keyword discard. So discard does not cause errors if items are not found. So for example, fruit discard grape. Our set contains cherry, elderberry, dates, apples, and figs. So there is no grape. So if we remove this, or even if we discard the item grape, then grape is not in the set, but there will be no error. So if we call out the set, which was now fruits, it's going to return the values cherry, elderberry, date, apples, and figs without returning an error. But if we use this, then it's going to return an error, because if we use remove, it's going to return an error because the keyword, the item melon was not found. Then the last one is pop. Pop is used to remove a random item. It is used to remove a random item. So for example, we have our another set, which is called popped. So popped is equals to fruits.pop. So in this case, what happens is that it removes a random item. It removes a random item. So let me first of all separate this into two different cells. So let us see what has been popped. What has been popped? We want to see the item that has been removed, because we've said that for pop, it will remove a random item, either cherry, either elderberry, either date, either apple or fig. So we want to see what has been removed. So you can see cherry is the one that has been removed in this case. So let us print out the set again and see whether cherry is going to be included after the popping or even after removing cherry. So after removing cherry, what remains is elderberry, dates, apples, and figs. And this concept is majorly important. You can assume, you can think of a time when maybe you are having a very, very large data set, or even you are having very many rows and you do not know which one to remove. You're just working with maybe the theoretical data, and you want to do away with maybe one row or maybe one column or even maybe one value. You just use pop and it will remove a specific value without, it will just remove a specific item, a random item from that specific set. And that is what happens. So that is it. And then we have clear. Clear is majorly used to remove all the items. So clear is used to remove all the items. So if we clear, for example, if for example we use fruits dot clear and then run that, let us call it out and see whether we are going to have any values. So fruits. So you can see after using the word clear, what is returned is an empty set. So clear will clear out everything, all the items within that set, elderberry, dates, apples, and figs. So what remains is just an empty set, which is this. And that is what happens. So these are the different ways in which we can remove or add items from a set. Now, the next one is mathematical operations. Mathematical operations. So sets support mathematical operations like in mathematical classes. So we have different mathematical operations that we can use on sets. The first one is union. So union, this is the symbol for union. So union combines all the items from sets, from the two sets, removing any duplicates. That is what we said. So it will remove any duplicates. That means that if an item appears in maybe set 1 and it also appears in set 2, it will return only one value. It will remove all the duplicates. And then we have intersection. Maybe before that, let me just write something. So for example, if set A has 1, 2, 3, 4, set B has 3, 4, 5, 6. Those are the different sets, set A and set B. So what will happen if we use union, that is A union B, this will remove any duplicates. For example, 4 and 4, they are appearing in both sets. So it will return only 1 4. 3 and 3, they were also appearing in both sets. So it will only return only 1 3. I hope that makes sense. Then the second one is intersection. The second one is intersection. This is a sign for intersection. That is a sign for intersection. So this one returns only items that are common to both sets. Which items are common to both sets? For example, here we have 1, 2, 3, 4, and 3, 4, 5, 6. So the items that are common in both, it's 3 and 4. 3 and 4. So if we use the intersection, then our values or even our output is going to have only 3 and 4. Only 3 and 4. Those are values that are found within the two sets. They are common. And then we have difference. Difference. Difference returns only items. Difference returns, or even it is also called the minus. We can also call it the minus. We can also call it the minus in that case. Yeah. So this one returns, it returns items that are found in the first set, but not the second. So for example, the first set has 1, 2, 3, 4. The second one has 3, 4, 5, 6. So 3 and 4 are common. These ones are common in the two sets. So the items that are found in the first set, it's 1 and 2. So 1 and 2, they are the ones that are found in the first set alone. So the syntax in this case, it will be A dot difference B. So I want the values in A that are not found in B, and that will return 1 and 2. And then the last mathematical operation is symmetric difference. Symmetric difference. Symmetric difference. Now, symmetric difference, this is a symbol for symmetric difference. That is a symbol for symmetric difference. So what symmetric difference does is that it returns items in either set, but not both. The items that are found in either set, but not both. So it will remove the duplicates. These are the duplicates, 3 and 4. These are the duplicates. They are found in the two sets. So it will remove those duplicates, and then it will return the values that are found in only A and only in B. So for example, 1, 2 is specific to A, and 5, 6, that one is specific to B, is specific to B. So it will return 1, 2, and 5, 6. That is what we call symmetric difference. And this is the method. So A dot symmetric difference B, and that is it. These symbols are very, very important. They make our work easier. They make our work easier. So you should master the meaning of each. So for union, we've said that it removes duplicates. Intersection, it will just give you the common elements. Difference, it will give you the values that are in A but not in B. And then for symmetric difference, it will give you the values that are in A alone and B alone, but not in both. And that is what happens. Okay. Let me explain that using a diagram. Diagrammatically, we have this. So for union, we are only interested in the values. We are only interested in the values that are appearing in both sets, but not duplicates. So it will pick the values from A, all the values from A, and all the values from B. Any duplicates would be disregarded. So any duplicates would be disregarded. So this zone here, we are not going to be using it. For that zone, we are not going to be using it. This zone is not going to be used. These are now the duplicates. Then for intersection will return the values that are common to A and B. So for intersection, we are interested in the middle zone. The middle zone. That is the values that are common in both sets. Values common in both sets. And then for difference, we are only interested in the values that are common to A alone. So in this case, difference will output the values in A alone, the values that are in A alone, those values that are in A alone and not in B. So we are only interested in the values for A alone that are not duplicated. So this zone is not going to be taken, and also B is not going to be taken because that we are not interested in that. And then for symmetric difference, it will give you the values in A and in B. The values in A and B, disregarding all the values that are shared by the two. So any value that is in A and B shared by A and B will be disregarded. So we only output the values in A and the values in B. Values that are either in A and B, but not in both of them. So they are only specific to A and specific to B. And that is it. That is it. Okay. The next part, we are now going to be handling examples. So assume you have a set A, which contains 1, 2, 3, 4, and then set B contains 3, 4, 5, 6. So if we print A union B, A union B is the same as A union B. In this case, we can use the words themselves, or even we can use their symbols. We can use their symbols, and they will return the same thing. Okay, let me separate that. So, and then run it. So if I print A union B, it's going to remove all the duplicates. So 3, 4, they were actually appearing in both of them. So we are only going to pick one value, 3 and 4. So if 3 is appearing in both of them, we are going to only have one of them appearing in the output. Or we can also have this, A union B, and it will actually return the same. And then for intersection, we can have A intersection B. In this case, we are interested in the values that are common to A and B. They are in the two sets. So 3, 4 is appearing in both A and B, and that would be the output. So if you use intersection A dot intersection B, then it will return 3, 4. We can also use the symbol in this case, the and symbol, and it will actually return the same 3, 4. And then we can also use difference. Difference is used whenever you want to get values. Whenever you want to get values that are common in A alone, or even that are found in A alone and not in B, in A alone and not in B. So, for example, if I run this, I'm going to get the values in A alone. 3 and 4 is common to both of them, so we remove that. So what remains is 1 and 2. These are the only values that are found in A alone and not in B. And we can do the same. We can do the same. We can also use A minus B. It will still give us the same. And besides that, we can also reverse the order. So if I wanted the values that are in B alone, then I'll have B minus A. I will have set B minus set A. And that will give me the values in B alone. That is 5, 6. So if you look at this, 3, 4 is appearing in both of them. So the values that are specific to B alone, it's 5 and 6. What remains here, it's 5 and 6. And that is it. Okay, so that is difference. And then the last one is symmetric difference. So symmetric difference picks the values that are specific in A, which is 1, 2, and the values that are specific in B, which is 5, 6, and then it merges them together. So for example, if we run that, we are going to have 1, 2, and 5, 6. Those are the values that are specific to A and specific to B. They are not appearing in both. They are only specific to A and B. Or we can also use the symbol. In this case, we can also use the symbol, that this power symbol that represents symmetric difference in sets. Okay. We can also have two sets of numbers. So for example, set 1 and set 2. Each one of them has different numbers, 1, 2, 3, 4, 5. Then in this case, we have 4, 5, 6, 7, 8. So if we print set 1, let me first of all run that. So if I print set 1 alone, I'm going to get the values for set 1 alone. I can also print set 2 alone, and I'm going to get the values for set 2 alone. I'm going to get the values for set 2. This one should delete that. So I have all the sets. In this case. I have all the sets. That is set 1 and set 2. So I can now union them. So if I union them, then we expect the duplicates like 4, 5 to only, we have multiple values for 4. So we are only going to have one value for 4. And then 5, it's only going to have one value. So duplicates are going to be removed. And then we are only going to have unique values. So set 1, union set 2 will give us these values, 1, 2, 3, 4, 5, 6, 7, 8. So the 4, 5, which was appearing in both is going to be, the duplicate is going to be removed, and we're only going to remain with only one value or even one entity. So set 1 intersection set 2, this will give us the shared values, which is now 4, 5. So if you run that, you are going to get 4, 5, which is appearing in both. So 4, 5 is appearing in both the two. If you look at this, 4, 5 is appearing in the first set and also in set 2. So it's going to be the output if you use intersection. And then if we pick set 1 minus set 2, that is difference, it's going to give you the values in set 1 that are not found in set 2. And that will be 1, 2, 3, 1, 2, 3. 4, 5 is 4, 5 was appearing in both. So the values that are only in set 1 and not in set 2 to be 1, 2, 3. Let me do the same. Let me copy this. I want the values that are now in set B, set 2, and not in set 1. So that will be set 2 minus set 1. So if I pick set 2 minus set 1, or even set 2 difference set 1, that will give me the values that are only found in set 2 and not in set 1, which is 8, 6, 7. Those are the values that are in set 2 and not in set 1. Look at the way the values have actually been arranged, 8, 6, 7. Our original set had 6, 7, 8. So the values are not ordered by any chance. They are not ordered. So if I pick now symmetric difference of 1 and set 2, I will get the output, which was the values that are specific to set 1 plus the values that are specific to set 2 alone. And that is what I'm going to get as the result. So if I run that, the symmetric difference of set 1 and set 2 would be 1, 2, 3, then 6, 7, 8. 4, 5 had actually been duplicated. That is why we are only going to get these values which are specific. Now, this is a practical example. This is a practical example on how to remove duplicates. So one of the most common uses of sets is to remove duplicates from a list. So a list with many duplicates, if you have a list like this that is having so many duplicates, then you can just change it into a set. This was a list. This was a list. If I run that, it is going to output the values as a list. Remember, a list uses square brackets. So this is my original list. So if I want to remove this duplicate, I just convert this into a set. So what I do is that I'm going to come up with a set name, which is unique numbers. So unique numbers is equals to, then I'm going to have the list. I'm going to have the list, then followed by set, and then the name of the list. What was the name of the list? The name of the list was numbers with duplicates. So I'm going to change that into a set, and then I print it. I think okay. I should have a set, and then yeah, it was supposed to be the other way around. So unique numbers is equals to set. So we precede our list with the word set, then followed by it is a list. Our numbers with duplicates was a list. So we convert that into a set. And what we get is now a set which has 1, 2, 3, 4, 5, 6, 7. Now, we can also do away with this. Let me remove this. I can also remove the list, the keyword list, and I'm going to get the same value. So unique numbers is equals to set, then followed by the name of the list. What was the name of the list? It was numbers with duplicates. So we convert that into a set. So anytime you precede a specific list with maybe a set or even a tuple, that would mean that you are actually converting it into that specific. You are changing its type. You are changing its you're changing the structure of that data. So you can change a list into a set. You can change a list into a set. And this is what we have after changing. So that marks the end of our third session on data structures, Python data structures. So next in line, we are going to be discussing about dictionaries. So stay tuned and ensure that you subscribe to this channel. You can also ask any questions that you might have within the comment section, and I'll be able to reach out. Apart from that, I'm also going to share this specific notebook with you. I'm going to share this notebook with you so that you can be able to follow along. So thank you very much for joining, and enjoy your learning.